Okay, so I want to do a quick demonstration, again, for those of you who need extra help with doing a Hess's Law problem. So we have right here the main reaction that we want to get the heat of enthalpy for. And we are given these known reactions. And what we have to do is come up with a reaction that's going to sum up to the one that I highlighted in yellow. So I'm going to take a look at what my products and what my reactants are. I see that my reactants are 4 NH3s, 5 oxygens, and those are my total reactants. My products are 4 nitrogen monoxides and 6 waters. So I'm then going to look down at my given known reactions, and the first one that I'm in the hunt for is my NH3, and I see NH3 right here. So I'm going to use that one as my first reaction. Now, I need 4 NH3s, 4 ammonias, in my reactants, and I've only got 2 here, and it's in my products. So first thing I'm going to do is I'm going to flip my reaction so that the NH3, which is the product in my known, becomes my reactant that I need for my given reaction. I'm then also going to double my reaction. You're really not helping me, you know that.
Katie always helps.
I'm then going to double my reaction because my known is 2 ammonias and I need 4. So I'm going to say 4 NH3s decompose into 2 N2s plus 6 H2s. And that way what I've done is I flipped it so that I now have ammonia as my reactant, and I've doubled the whole reaction so that I have the amount I need, 4. So this means that I'm going to have to double and invert or make positive my given heat of enthalpy. So my given heat was negative 91. I'm now going to make that positive, and I have to double the amount. So taking out my calculator, 91.8 times 2 equals 183.6. Now that's going to be positive 183.6 kilojoules. I'm now going to go and look for my next reactant. Okay, now in this case, oxygen is my next reactant, and I've got oxygen in 2 places here. So I'm going to leave the oxygen for right now, and I'm going to go to something a little simpler. NO4 is something else that I need. I need it as a product. And I see in this first reaction, I've got NO2 as a product. So I'm not going to have to worry about flipping my reaction. Katie, I don't think you're qualified to teach chemistry. So let's have you just sit. Okay. So instead, I'm going to just have to double it. Okay. So I'm going to say 2N2 plus 2O2 yields 4NO. So now I've got the 4 NOs that I'm going to need. I didn't flip this reaction, so I'm still going to keep it as negative. So that's going to be negative and I have to double 180.5. Now that doubling I can do in my head. I don't need my calculator for that. That's negative 361. So now I'm going to go down to my last reaction. And I'm going to see that I need 6 waters, okay, to form this one. Well, this has also got water as a product. So I don't have to worry about flipping my reaction, just like the other one. But I'm going to have to triple it because I'm only forming 2 waters with my known reaction, and I need 6 for my given. So I'm going to triple the whole reaction. 6H2 plus 3O2, oops, typo, plus 3O2 yields 6H2O. Now, I tripled this one. I didn't flip it, so it is still going to be negative, but I tripled it, so I'm going to have to multiply this given heat of reaction by 3. So 483.6 times 3 equals 1,450.8. 1,450.8 kilojoules. Okay. My next step is I need to make sure that everything is adding up to my correct given reaction. So let's see. First thing I see is I've got my 4 NH3s in my reactant, which is what I want, and I'm going to look at my products. I don't have any NH3 anywhere in any of my products. So that means this is going to stay as 4NH3 when I go to write my final reaction, 4NH3. Now, the next thing that I come across is 2 N2s in my product. So I'm going to look down here to see if I have any N2s in my reactants, and I do. So that means that I'm going to be able to cross this off. So let me see if I can get my drawing menu up. I can't.
You can move that. Move it down.
It doesn't want to move. So I'll just do it this way.
No, you won't.
You're not helping.
I never am.
I'll just strike it through. Okay, so that one's dealt with. Now I see I've got 6 H2s also in my product. Well, here I've got 6 H2 in my reactant. So I can strike that one through. Okay. Now, let's take a look at what else we've got. We've got O2. I don't have O2 listed in my product in either of the other 2 reactions. So, because they're just reactants, they're going to have to just get summed. So that means plus 2 plus 3 gives me 5 O2s. And now I take a look at my products. I've got 4 NOs. I don't have NO anywhere else, so that's going to stay as is. And 6 H2Os. That's going to stay as is. And I double check. This is indeed what my original reaction was supposed to be. Now, all that's left for me to do is to add up my energies. 183.6 plus or minus 361 minus 1450.8 equals negative 1,628.2 kilojoules. And that's how we do that.